In this video, we will derive a formula for permutation with identical items and without replacements of n objects taken n-1 at a time. A boat has 8 signal flags only and wants to communicate visually using signals composed of more than one flag. The question is how many compound signals can be created by arranging the 8 flags in order over one line. The first step is that we map these flags into A, B, and C. So we map the first set of identical items and the second set and the third set. Now for each ordered arrangement of these flags, we have an ordered corresponding word. After that, we write the flags in this ordered list as we see here. So we have 2 identical A's, 3 identical B's, and 3 identical C's. And the total is 8. So now we apply the formula of permutation with identical items and without replacement. And this is the formula here. We substitute A, B, C, and N, and we get 560 signal flags we can create out of this list here, or out of the flags we have seen before. The second question is how many compound signals can be created by arranging the 7 flags in order over one line. So we have this word here and the total number of letters in it is 8, and we want to create a 7-letter word out of it. So how can we do that? We can either take A off, we end up with 7-letter word, or we can take B off, or we can take C off. So let's do that. First we take letter A off and we end up with 7-letter word. And the second case, we take letter B off and we end up with a 7-letter word. And the third case, and the final one, is that we take letter C off and we end up with this 7-letter word. The number of compound signals that can be created by arranging the 7 flags in order is equal to the number of permutation of the following 3 words we have found before. So these 3 words, each one 7 letters. Now we write the corresponding permutation of each. For the first one, we have here 7 letters and we have here 2 minus 1 because we took 1 letter A off. And here we find 3 minus 1 because we took 1 letter B off, and here we found 3 minus 1 because we took 1 letter C off. Now we add them together and we get 560 signal again. And this is the number of compound signals that can be created by arranging the 7 flags out of 8 in order. We are going to use the following notation: permutation without replacement of 8 objects taken 7 at a time for 2, 3, and 3 identical objects. And in abstract way, we can say that this is permutation without replacement of n objects taken n-1 at a time for these identical objects. So we notice the following, that permutation without replacement of 8 objects taken 8 at a time is equal to permutation of 8 objects taken 7 at a time. So is that always the case or not? This is what we have to find. So let us now review this notation here. So this is permutation, which implies order, and since nothing is written here, so it's without replacement of n objects taken m at a time for A, B, and C identical objects. And we write here 2 semicolons in order to create separation between the identical items and the objects. And we read that permutation without replacement of n objects taken m at a time with A, B, and C identical objects. And now going back to the permutation numerical terms we found before, we are going to replace every number with its corresponding symbol. So we replace 8 by n, 2 by A, 3 by B, and this is 3 by C, and we keep doing that until we finish. And now we can say that in general, if we have a word with n letter with A, B, C identical letters, then the number of n minus 1 letter word that can be formed out of it is given by this general formula here. But we know that n factorial is equal to n times n minus 1 factorial, which allow us to write n minus 1 factorial is equal to n factorial divided by n. We can do that also for A minus 1 factorial, B minus 1 factorial, and C minus 1 factorial. We substitute now these terms in the sum of permutation formula we found before. So we replace n minus 1 factorial with n factorial divided by n, and we replace A minus 1 factorial with A factorial divided by A, and we do that for the rest of the terms. And we notice that now we have the same denominator, so we add the numerator here, but we notice that A plus B plus C is equal to n. So we replace the sum with n, and now we can cross off n from the numerator with n from the denominator to get exactly the same formula as before. So we notice that permutation of n objects taken n at a time is equal to permutation of n objects taken n minus 1 at a time for the case of same identical objects and no replacement, and both can be computed from this formula. So this is the final formula, and we notice that this result is strange. However, it is proven to be correct, and I didn't find it in any book. Thank you for watching and have a good day.